This video describes our approach to defining the process limits and capabilities for any aggregates operation using belt scale data. The process begins by defining the process, actually mapping the process, establishing the process layout, locating stockpiles, identifying the processing equipment, including the conveyors, and then generating a map, often a flow chart. Once that flow model has been created, alternatives are evaluated to establish the variations and configurations that are physically possible within the design of the process to create multiple modes of operating, which likely will have different production rates and capabilities and limits, as well as variations in the yield of key products and byproducts. The plant layout is usually obtained from an aerial photograph or a Google Earth. It can be done by hand sketch also. Stockpile locations are determined so that it can be established what conveyors lead to what product. Basic configuration of the processing system is necessary so that the equipment limits and capabilities can begin to be defined, at least based on manufacturer recommendations or field observation. Conveyors are all necessarily defined in detail because they are often the bottleneck in the process, and we also need some basic information to be able to establish what type of belt scales are necessary and where they'll be located. Flow model is an analysis that shows the material coming in, going through the crushing system, going to the screens, and eventually coming out as products. The system requires field measurement initially to be able to establish what the limits and capabilities in the as-is condition are, and that's done with field sampling, or in this case digital photo imaging, leading to a point where we got enough information on the process side so we can go back to the pit side to make sure that it has the capabilities to match what the processing side is capable of doing. With that information, we establish the potential yield and capacity rates for the various modes that we initially define, and begin the process of locating belt scales. The belt scale information is the key to understanding the heartbeat of your process. The crushers are the point where the work is being done, so the performance of the crushers is critical. It is the heartbeat of your process. The pulse of your process is measured using the belt scales. Belt scales are located on the infeed side and the output side, but the most important belt scales are the ones that are within the crushing circuit. Once the belt scales are in place, it becomes possible to evaluate in real time at 5, 10, 15 second intervals the variability that is occurring in the process, as well as the yield and the rate. The information can be looked at in a variety of forms and include self-defined or locally defined targets, or targets defined from the data system analytics. This shows an example of the scale data overlaid on a process flow model, which would then be the indication to the operator how the plant should be configured to achieve the results indicated for the particular mode selected. Detailed analysis can be carried into a combination of measurements that reflect what's going into the crusher and what's coming out in terms of the key products and the byproducts. The purpose of the analysis is to establish how to operate the plant to increase the yield of key products, thereby reducing the number of hours required to achieve the forecast production related to current sales. Once the scale system has been in place, the system automatically begins processing the data and generating reports that can be used to evaluate current performance as well as historical performance. This is what the scale data looks like when it comes in. It is recorded by the hour in terms of tons and minutes for each of the individual products. The system automatically generates reports showing the details for the different segments of the process, again by the hour, and including the tons and the operated minutes. with a bit of analysis of the summary results. This is a 24-hour report, automatically emailed at the before the beginning of the next day. There's a 7-day summary, so you've got a comparison of today's production or yesterday's production against previous performance. Individual scales data is shown, including the tons and the operating hours, all the critical statistics. This is date selectable. Also, you can go back and look at previous dates. The year-to-date results are summarized in detail for each of the scales. The month-to-date is included, the past 10 days, the past 30 days, and the past 60 days, or whatever. And again, that's date selectable. We have a basic or very rough projection that we use, or we provide using the year-to-date information, along with an estimate of how many more weeks of operation are going to occur, so that we take previous performance and project end-of-year results for the number of over the number of weeks that is left. It can be seen in the year-to-date data that capabilities in terms of ton per operated hour, ton per scheduled hour, and percent runtime give you an idea of what the as-is issues and limitations might be. You'll also note that the yield detail is accumulated. The cumulative data from all of the belt scales is also automatically extracted and analyzed on a daily basis for each scale to establish the performance benchmarks and capabilities. We take the top 10 days in this example of output in terms of tons for each of the individual scales and calculate from that. The auto-updating benchmark capacity and yield evaluation gives us a clear picture of what the maximum capabilities of each of the products that are being measured over a conveyor belt. Not just the products, but also the infeed and the circulating belts. So we can establish what the realistic limits and capabilities of each individual measured conveyor system might be. We use that in combination to evaluate under various circumstances what the potential yield in terms of key products and byproducts would be, what the potential tons per hour of those byproducts and key products, and also we look at the amount of time that is scheduled is actually run and evaluate the uptime or the run time. With this, the process limits and capabilities for any operating quarry can be established in detail that has never really been practical before. Simply using belt scales to measure the operating variables, using the real-time interface to kind of begin managing the operating variables. The issue with managing data is taken care of by the system, with it automatically generating reports providing the analysis of current performance necessary to evaluate potential improvement.